Hi, Danny. Welcome to lesson number 79. This lesson is going to be super fun. And it's funny because earlier this week you were talking to me about symmetry. And I was like, hey, you didn't even do that lesson yet. We are going to learn about symmetry and what is symmetrical. And I think this is going to be super fun. I think you're really going to like it. But first of all, why did the boy do multiplication problems on the floor? His teacher told him not to use tables. Get it? Because I think she meant these kind of multiplication tables. And he's sitting there doing his homework on the floor so he doesn't have to use tables. Aw. At least he was trying to listen to his teacher, so that's good, I guess. All right, we are going to start out with your multiplication facts, and you are going to have 5 minutes to do it, okay? On your mark, get set, go. All right, I'm going to stop you right there, Danny. Okay, that was fun. That was Mozart we were listening to, so brain music, that's for sure. Okay, so for mental math, we're going to do something a little new. So they're teaching us a new thing here about when we subtract two-digit numbers. So they say that when we're subtracting two-digit numbers, so that's a number like 30 is a two-digit number because there's a 3 and a 0, or it could be 32 or 68, any two-digit numbers. It's easier if the second number ends in 0. Okay, so if you're subtracting like 60, well, let's say maybe like 62 minus 60, it's easier to do that problem than 62 minus 59, right? The first one is easier. So it's easier if the second number ends in 0. So we're going to rewrite some of these problems so that the second number ends in 0. And they give us an example. So instead of this problem, 45 minus 28, you can think of this problem. Now, how did they get that? Well, it looks like they added 2 from 45 to 47, okay? And then here it looks like they also added 2 from 28 to 30. So they did the same thing, and as long as you do the same thing to both of the numbers, then it keeps the answer the same. Let's make sure that it keeps the answer the same. Let's do 45 minus 28. So to do this problem, we would have to, 5 minus 8 looks like we would have to borrow a 1. So let's make that a 3 and turn that into 15. 15 minus 8, what is that? 9, 10, 11, 12, 13, 14, 15. So it says 15 minus 8 is 7. And then you have 3 minus 2, which is 1. Okay, so we got 17 there. 47 minus 30. So let's subtract the ones placed first. So 7 minus 0 is 7, and 4 minus 3 is 1. That was definitely easier. And look, we got the same answer. We got 17 here and 17 here. So as long as we do the same thing to both of the numbers, adding 2, then we can make the difference between the two numbers is going to be the same. Okay, and what they did to figure out, well, how did they figure out to add 2 instead of adding something else? Well, they looked at the second number and they tried to make that easy by making it a number that ends in 0. So to get from 28 to 30, they figured out, well, I'm going to have to add 2 so that that becomes a number that ends in 0. Okay, I'm going to do another one with you. And I know this bunny's like, I can't do it. It's too hard. But it's not too hard for you. I'm pretty sure that you can handle this, Danny. All right, so let's try this one. The question is written 45 minus 39. Now, this is a little tricky because this number does not end in 0. So instead of that, I'm going to do 40. I'm going to change it to 40 on the bottom. What did I do there? I added 1. So I'm going to add 1 to the top number. Instead of 45, I'm going to write 46. And now I'm just going to subtract 46 minus 40, and the answer is 6. Sweet. Okay. That was easy. And that's the answer to this one, too, 45 minus 39. That's the whole point. You get the same thing both times. All right, let's do B. And there's a Mercedes to look at. Are you impressed that I knew what that was? Alrighty, let's do this one. So 56 minus 27. So I want this number to end in 0. So I'm going to change it to 30. So what did I do to change it to 30? I had to add 3. So let's add 3 to the top one. 56 plus 3 is going to be, what, 59? And now I'm doing 59 minus 30. And what do I get? A 9 in the ones place and a 2 in the tens place. So it's 29. Okay, I'm going to begin to help you with the next one, but I won't give you the answer. and then you can figure out the answer on the next one all by yourself. Okay, so I'm looking at this one. I want to change this into a number that ends in 0. So I'm going to make it 50. What did I do to get 50? Well, I added 2. So I'm going to add 2 to the top. And it's going to be 65. Now all I have to do is figure out what is 65 minus 50. And that's going to be the answer for C. And then D, you're going to do this one all by yourself. 82 minus 35. Remember, you want to make this one into something that ends in 0. Cool. Okay, and let's go on to the new concept. And this new concept is super cool because turns out in nature, we often find balance in like the appearance of something and in the structure of objects like, I don't know, like planets or something like that, but also of living things like me and you or like this butterfly. So for example, we see a balance between this side, it looks the same as this side. And the wing patterns are sometimes like exactly the same. See this line going up right here matches this line going up right here. That's cool, isn't it? And look at this one. This one's cool because it matches that one. That's so cool. And we call this kind of balance reflective. I'll write the word because it's a little hard. Reflective symmetry. What does the word reflective remind you of? To me, it reminds me of like my reflection in a mirror. And it turns out that if you were to put half of this butterfly, like hold half of it up to a mirror, the mirror would reflect this other side perfectly, right? So it's like a mirror image. That side and this side is a mirror image. So cool. So look at this dotted line that I drew down the middle. See this dotted line? That is the line of symmetry. And that means if you put a mirror right there, the mirror image is on the other side. So if you stood a mirror right here along the dashes, like you put a mirror, the reflection in the mirror would finish or it would complete the figure. Okay, cool. That's the line of symmetry, that dotted line. Now, sometimes polygons have one or more lines of symmetry. So some shapes have symmetry. Like think about it, a circle does, sometimes certain stars do, a triangle sometimes does. All right, so we're going to practice finding lines of symmetry. Let's go to example 1. That's on the next page for you. Which of these polygons does not have a line of symmetry? So let's look closely at A. Does this have a line of symmetry? Oh yeah, it certainly does, doesn't it? So you could put a mirror right down the center of it. Whoops, I didn't draw a straight line. Let's see if I can fix that. Okay, let's draw a straight line. Perfect. All right, so if I put a mirror right here, this side would be a mirror image of this side. Cool, huh? But guess what? That's not all. That is not all. What if I put a line here? The up and down, that is also a line of symmetry. Pretty cool, huh? So it has a line of symmetry here and a line of symmetry here. It does not have a line of symmetry here though, because that's not exactly the same. If it were the same, then it would look more like a kite. Okay, but it already has 2 lines of symmetry there and there, so that's pretty cool. All right, so what about B? Does this have a line of symmetry? Oh, yes, it sure does. This looks like an isosceles triangle where this is the same as this. The lengths are the same, and then this one's shorter. Whoops, that one's shorter at the bottom. So where would the line of symmetry be? It looks like the line of symmetry would be here. And if it really is an isosceles triangle, that's the only line of symmetry. I kind of made it to look like an equilateral triangle. If I made it a perfect equilateral, then there would be another line of symmetry there and there. Whoops. But it's supposed to be an isosceles triangle, so the line of symmetry is there. Maybe a little, there we go. Oh, you know what I mean, like right down the middle, right there. Perfect. All right, what about C? Does this have a line of symmetry? It definitely doesn't look symmetrical. Like if I draw a line down the center of it, this left side is not a mirror image of this side because those look different. What if I move the line of symmetry so it's like that? Nope, it still doesn't work. It's still not symmetrical because this side does not look like this side. Okay, so C is not symmetrical. Okay, all right, perfect. So the answer was C. That one does not have a line of symmetry. All right, about half of the uppercase letters in the alphabet have a line of symmetry. Whoa, that is so cool, right? So let's try it. Let's look at some letters and see if it has a line of symmetry. That's an example 2. Oh, guess what? This design, perfectly symmetrical. Symmetry makes some really cool designs, I think. Okay. It says, copy these letters and draw each line of symmetry if there is one. All right, so let's look at the letter C. If I made it perfect, is there a line of symmetry? Well, there's not an up and down line of symmetry because this side does not look like this side. But if I draw a line of symmetry here, then the top does look like the bottom if I draw it better than I did. But this looks the same as this if I draw it perfect. So that's a line of symmetry. Okay, let's look closely at the letter H. Does it have a line of symmetry? Yeah, it definitely looks symmetrical. So what if I draw a line down the middle? Does this side look like a mirror image of this side? Yeah, it does. It looks like a perfect mirror image, but that's not all. If I draw a line through it this way, then this top side looks exactly like the bottom side. So this one has 2 lines of symmetry. Okay, what about the A? There's an A in your name. Is it symmetrical? Yes, look at that. This side is a perfect mirror image of this side. Cool, huh? There's no up and down line of symmetry because this is a pointy part and this has legs like that. So up and down, it's not the same. What about the letter I if it's just written like this? If it's written like this, we do have a line of symmetry this way because the top is a mirror image of the bottom. And we also have a line of symmetry this way because there's just a little edge there and a little edge on that side. So this has 2 lines of symmetry. One there and one there. Cool, huh? What about the R? The R does not look symmetrical. So if we draw a line of symmetry here, the left and the right don't match. And if we draw a line of symmetry here, the top and the bottom don't match. So this one is not symmetrical. Okay, cool. Now, you have an activity sheet in your homework for today. So get out your activity sheet number 25, and there's also going to be a mirror in your homework. And so you have to use the mirror to find the line of symmetry in all of those shapes. Okay? And when you're done with that, you still have your math homework. So don't forget to do the lesson practice and the mixed practice. There's an interesting on number 2 in your line of symmetry on the activity sheet 25, and I put this at the very back of your homework. There's a pencil that looks like this, and it has a pointy end, and it has an eraser here. Don't forget that you can draw a line of symmetry straight through the pencil. It can be a diagonal line. So a line of symmetry can be a diagonal line. That's okay. All right, so just remember that. Here's a kitty being symmetrical. Look at it in the mirror. So cute. All right, knock, knock. Who's there? Tank. Tank who? You're welcome. You're welcome for this lesson and also for paying attention. Thank you very much and good luck doing your homework. Okay, Danny? Love ya. Bye.